Everyone, in today's lesson, we're going to talk more about the definite integral, this time with trigonometry. So before we do anything, we need to recall the following derivatives. The derivative of sine is cosine of u, and then times the derivative of the inside, or the derivative of u. Derivative of cosine is negative sine, and then the derivative of the inside. Derivative of tangent is secant squared, then times the derivative of the inside. So if we don't have any inside other than x, then it's just going to be as follows. So if my function is y equals sine of x, then my derivative, dy over dx, is just going to be cosine of x, and then times the derivative of x is just 1, right? The derivative of the inside. So just cosine of x. So then over here, if I have y equals cos x, and I want to find the derivative, dy over dx, we know that that is going to be negative sine of the inside times the derivative of the inside. The inside of x, the derivative of x is just 1. And then last but not least, if I have tangent of x and want to find dy over dx, that's just going to be secant squared of x times the derivative of the inside again. The derivative of x is 1. So we can use these basic derivatives to show what their antiderivative would be. So if the derivative is cos, where did it come from? Sine. So this would be sine of x plus c. Then if I have the antiderivative of negative sine, if that's my derivative, where did it come from? Cos. So cosine of x plus c. And then if I have secant squared as my derivative, where did that come from? Tangent. So tangent of x plus c. So the sines and cosines one are going to be a little bit challenging when I start adding negatives and positives. So we can use what we learned earlier in the year for derivatives, sine, cos, negative sine, negative cos. We went from left to right when we were doing derivatives, f prime of x. So what we're going to do is go from right to left when talking about integrals. So if I want the integral, say for example of cos, I go backwards to sine. If I want the integral of negative sine, I go backwards to cos. And then that's my answer. So you just read them backwards for integrals, forwards for derivatives. And obviously the antiderivative of secant squared, that's going to be tangent. So that one will just be something you'll have to memorize. So let's take a look at an example. So example number 1 says, evaluate the definite integral and express your answer in an exact value in simplest form. So I'm going to first write again one more time, sine, cos, negative sine, negative cos. So I have the integral of 2 sine of x. So I'm going to start at sine, and instead of going right this time, I'm going to go left, so I have to go back around. So the antiderivative would be negative cos. So since I'm starting with 2 sine, the answer is just simply going to be 2 cos of x, and I want to integrate that from negative pi to negative pi over 2. So we're going to substitute top and bottom here. So 2 cosine of the top, which is negative pi over 2. So this part is my top. All I'm doing is substituting negative pi over 2 for this x. Then I'm going to subtract the bottom, which is 2 cosine of negative pi. And in order to answer these or to simplify them, you either need to use the unit circle or quarters or for sodas. So it would be helpful if you had the following degree measurements memorized. So we have 0, 90, 180, 270, and 360. So it would help if you knew that 90 degrees was pi over 2, that 180 degrees is pi, and that 270 is 3 pi over 2, and that 360 is 2 pi. So we have negative angles here. So obviously when we go counterclockwise, when we're going around the circle in this direction, we go from 0 to pi over 2. So it would be helpful as well if you knew going negative direction would be going clockwise. So this is 0. This one down here is also negative pi over 2. Then we keep going around. This would be negative pi. This would be negative 3 pi over 2. And then following it around would be negative 2 pi. So you can go positive direction or you can go a negative direction. So 0, negative pi over 2, negative pi, negative 3 pi over 2, and then a negative pi. So if I want to evaluate cosine of negative pi over 2, remember in a unit circle, this might be helpful, that the x value is cosine of the angle and that the y value is sine of the angle. So in this problem, I'm looking for cosine of the angle. So I'm looking at the x value only. So cosine of negative pi over 2, we're going to look at this angle measurement, and we're going to focus our attention solely on the x value. So that x value there is 0. So this cosine of negative pi over 2 is 0. We're going to multiply it by this 2 that's in front. So 2 times 0 gives me 0. And now I'm going to subtract 2 cosine of negative pi. So I need to find cosine of negative pi. So if we go to the angle measurement of negative pi, we're going to look again at my x value. So my x value, whoops, sorry about that, we'll fix it. My x value here is negative 1. So I've got my 2 in front still. And then this cosine of negative pi is negative 1. So if we keep this in brackets, we'll see what's happening. We've got 0, and then 2 times negative 1 is negative 2. So we've got 0 minus negative 2. That's a double negative there. So it's really saying 0 plus 2, which is 2. So that is my evaluation of this definite integral using trigonometry. All right, let's try another example. So same concept, evaluate the definite integral. I've put a exact value chart up here because we're probably going to need it for this example. Remember these conversions that would be helpful. 30 degrees is pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3. So again, we're going to write down sine, cos, negative sine, negative cos, and the antiderivative of negative cos. So we're going to start here at negative cos and go back this time. So it's going to be negative sine. But since there's a negative 2 in the front, we're just going to be negative 2 sine of x. And we want to evaluate that from negative pi over 6 to 3 pi over 4. So just like we did before, we're going to plug in our top and our bottom. So negative 2 sine of 3 pi over 4 minus negative 2 sine of the bottom, which is negative pi over 6. So in order to finish this problem, we just need to evaluate sine of 3 pi over 4 and sine of negative pi over 6. So in order to do this and this, I'm going to do it on the side separately, and then we'll put it back in. We need quarters are for sodas. So Q, R, F, S for both of them. So we need that one. And then we also need for sine of negative pi over 6. So the problem with this first one is that we've got it in radians. So it would be helpful if we can change this to degrees. So remember how we go from radian to degree is that we multiply by 180 over pi. And then the pi's will cancel. And then you're just going to multiply 3/4 by 180. If you do that and simplify in the calculator, you should get 135 degrees. So to answer the questions, 135 is an angle that's in quadrant 2. That's what Q stands for. The reference angle in quadrant 2 is 180 minus 135, which is 45 degrees. The function f that we're dealing with here is sine. And if we remember, all students take calc. Since we're in quadrant 2, sine is the only thing that's positive, so we read this from the bottom up. So it's actually equivalent to positive sine of 45 degrees. So positive sine of 45 gives me this. So all we have to do is go to our exact value chart and say, okay, here's sine of 45, and we get rad 2 over 2. So that goes in here, rad 2 over 2. And we have to multiply this by this negative 2 in front. You'll notice that the 2's cancel, so you're just left with negative radical 2. And we now need to subtract it from the value that we got here. So first, if we want to do quarters or firsotas for the same thing, we need to convert this negative pi over 6 into degrees. So negative pi over 6 times 180 over pi. If you do that, you should get negative 30. So negative 30 is not really allowed. You can only use angles that are between 0 and 360. So you have to use coterminal angles. So negative 30 plus 360, that's how you get a coterminal, would be 330 degrees. So we're going to use this angle here, 330. So what quadrant are we in? Q 330 would be quadrant 4. How do I find a reference angle in quadrant 4? It's 360 minus the angle, which gives me 30 degrees. The function I'm dealing with is sine. And the sine in 330, which is quadrant 4 means cos is the only thing that's positive. Therefore, sine would be negative. So if we read this from the bottom up, it's negative sine of 30. And you just look at your chart one more time. So sine of 30 is simply 1/2. But because it's negative, we have to put the negative in front. So it's negative 2 times negative 1/2. The 2's will cancel. A negative times a negative is a positive. And then this is just my final answer. This is the exact value of that. All right. I know I did a lot. I know there might be a lot of questions. So what I'm going to say is we will go over that tomorrow. If you would like, you could try question number 3, and we can really start there tomorrow in class. And don't worry if this is stressful for you, because we're going to do this for a couple of days. All right. That's it. Have a good night.